Okay. Chairman John, honorable guests, ladies and gentlemen. Okay, finally back to English. Okay. So I will try to speed up my presentations, and no worry. Although it is 3 o'clock, and my presentation lots of videos. Okay, you won't fall asleep. One page just introduce my center. Is one of the 5 R&D centers under Hong Kong government ITC. And as our name, we do research topics relating to logistics and supply chains. But the worst is that you know the name enabling. After the 2 presentations in front of me, you see lots of visions and plans. But we need to do what sort of an enabling technology. That means that we really need to work on site and correlating to logistics. So just another one page. Maybe you can very easily find on internet just concluding what is an IoT. So you just contain lots of sensor trying to simulate or doing very close to what are human beings' 5 senses. And then through different types of connectivities, like the nerve system goes to the processor, so for big data. But how to do it is a challenge. On daily basis for logistic industry, traditionally, it is a very thin margin industry, especially in Hong Kong. Most of the logistic players, except those well-known brands, are SME. Most of them nowadays only maybe 5 or less than 10% margins. So how they can spend investment on new technologies. And every day we encounter these 4 questions: one, what, where, when, who. But this is the old question. Now, thanks to Taobao, when you receive goods, then we need to ask what really they are. And in future, people in the logistics wants to know when a task will complete instead of just checking that what a task has completed in the past. And also for the locations, they have new requirements on what exactly the goods that delivers will be done, and who actually is doing these kind of tasks. So what the challenge for IoT device for logistics, basically with these 5 questions. Because when the truck's moving on the roads and from one country to another, or in special warehousings, when the goods is moving from one place to another, power supply, connectivities has problems. And also, the last point is the ROI. Is that your chosen technology really can be used in the industry? First of all, I will just introduce 2 or 3 projects, maybe 4 or 5 years ago we have done. Mainly will be related to the food safety. In 5 years ago, we worked with Guangdong inspection and quarantine departments because all 100% of the pork is import from China, and we are very cautious about the origin of the pig, from which farm, in case a problem happens. So, but of course, when they import, they have all the RFID ear tag. But we're facing the problem after slaughtering. The pig is turning into 6 pieces and goes to the market. So these detach to the RFID tag. So we've done projects that how to correlating that piece of pork to what exactly the ear tag it is. And we use a UHF, and we do it in the Shanghai slaughtering house and do lots of testing on UHF technologies. And then that data will pair with the barcode at the end, which is a very cheap, the most cheapable technology, so that the consumer or the retailers can afford. Similar for vegetables, is doing the same things from basket using the RFID and then correlating to the barcode. And also, we design a special tag antenna that you can put on a red wine's bottleneck or even behind the label, so that within the one carton box, without opening it, a user reader can checking 12 totally a dozen of red wine in one casing. So this is the traditional applications of RFID. And then next step, people will try to imagine how about we put in different sensors in the whole logistic chain. But honestly speaking, this is for implementation. It's not so easy. It's not all on technology, because if you want to tag different sensor through the logistics, you will come across battery problems and the cost. So maybe in the picture, vaccine, if you're delivering, then you can afford to put sensors on. But for normal frozen food, then most of them are unwilling to put all these sensor technologies on. So among all of these locations, one of the success projects coming up, say 4 years ago, is we worked with a custom. Then we built an e-lock project in which for Hong Kong logistic industry, for transshipment, contain almost 85 to 90% from China to the container terminal and then to the airport. However, 10 years ago, Hong Kong container terminals is still the #1 of Hong Kong ever. But now it turned out to be maybe the 6th or the 7th. But we still have the container terminal here, and we're still living for a huge group of people working in this industry. So how we can use technology to keep these industries moving? One of the bottleneck is we only have 4 or 5 coming boundary for these transshipment trucks. So we use this e-lock to digitize the locations, and also use an intelligent device so that if anyone trying to break it or open it, then the console in Hong Kong Custom will have the alert. And also the GPS signal will have the routing to check whether the driver is using the shortest route from the border to the container terminals. And one leap forward on this project is 2 years ago, Hong Kong Custom already worked together with China Custom, so that the one single e-lock can work or shake hand between 2 customs. Nowadays, within the Guangdong province, we have almost 300 different routes within Guangdong province. Then they don't need to drop by or stop by for checking for each custom checkpoint. And directly, for example, from Guangzhou Airport, you start to tape the lock and safeguard this container. You can directly drive to Hong Kong Airport without stop. And all the shake hand after you cross the border, the lock will shake hand and hands off with China Custom, and then hands on to Hong Kong Custom. And this is the fully launcher from 2 years ago. After that, another question is the locations. Where? In Hong Kong locations, especially from the subtropical zone, GPS locations or GPS data is not very accurate because of the geographic problems or the ionizing problems. So you may check if you use your mobile phones, checking your GPS location in the morning time, comparing with 3 o'clock night now, your GPS signals is different. And also in city level, or because of the reflections of the building, sometimes you cannot get totally free or above satellite signal. You cannot precisely locate your positions. And for logistics and for e-commerce and delivery, also in a high side on requirements for indoor locations requirements. So as our center, we invite several 7 major universities in Hong Kong with different professors. We conducted a series of real-time location basis of projects and have supported by several government departments and airport and Hong Kong Post. So later on, I will explain among these projects some testing or technologies. From left-hand side, from GPS, we how to recalculate it, and also how Hong Kong can using a technology to deliver more accurate GPS locations. In Hong Kong, with the support of Lands Department, we have totally 18 satellite reference stations. Now maybe every year they will increase 1 per year. So now maybe 19 to 20. And the idea is we try to use our company use handheld device. We know we are not using very expensive surveying grade GPS device. We have a server working with PolyU. So every minute, the reference station's data will send back to the server. And then our device will send our actual Lima data to the server. And the server will correct in real time with a differential GPS back to the cellular phone or any device or like installed in your trucks. That is the idea. And the result, you can see that is we do a demo, is one cellular phone, we just excluding all these Google data, just purely using the cellular phones, their own GPS chips. And one is using a mobile apps with the DGPS correction data. You can see that from purely relying on mobile phone GPS functions is around 4.1 meters in average, and improved to 0.4. In a sense that we hope this kind of these applications can promote to other users, so that in logistic industry, when they're doing the trucks delivery, they can do the real-time GPS signal with much more accuracy. So less than 1 meters, the meaning is almost, if you drive in the highways, is the 1 driving lane's accuracy. And most important is that the solution is cheap. You don't need to buy very expensive equipment to enhance. Another project we work for UST is using the Wi-Fi fingerprint for indoor locations. The idea is we expect any solutions, we don't need to install extra Wi-Fi devices or Bluetooth. We try to create a Wi-Fi indoor map and 3D indoor map, so that using our mobile phone, the Wi-Fi chips, I can scan the APs around so that I can match with the database Wi-Fi 3D map. And this project's the results we can done in the airport, passenger terminal 1, we can deliver up to 3 to 5 meters accuracy. Actually, this is a very challenging project, because you can imagine in the passenger hall of the departure hall, every corridor is the same. And Hong Kong Airport, the AP is putting in the same positions of every corridor. So you can imagine from the corridor A to J in the Wi-Fi map, in the database, the shape themselves is very similar. But still, ultimately, we can deliver around 5 meters is a very good result on that. And one of the hospitals on the video dance is also implement the system for a hospital for the navigation purpose. Okay. This is also another interesting project. Thanks to the e-commerce, this is the Hong Kong Post air mailing centers. This is not the busiest timing. It's the normal operation scenario. All these parcels is putting into this, they call it purple cart. When each cart is full, almost one person's height. So if all this cart is being filled up, basically I cannot see that one next to it, behind. Their problem is if next 5 minutes I need to find the right cart for the plane fly to Los Angeles. That is about 12 cart. So how I can pick correctly this 12 cart or find totally this 12 cards? This is a very problem for them because sometimes they will leave if they cannot find totally 12, only find 10. They need to put this 10 card on the plane and then left these 2 behind for another and reschedule it. Then we'll have a much more higher cost for another plane. The solution is we work with a Chinese university using our active RFID tag. We have our special design indoor antenna so that through RF, I can check all the indoor position for each card for this tag. And also can communicate with them. Okay, the console for the management office, they can input. For example, if I need to light on next 5 minutes, I have a plane fly to Taiwan, Taipei, then please light the red light on. Then all this, the correct one with the lights on, they can easily pick the correct card. And now they totally 3,000 cards are there. Okay, so you can imagine all this. So now they like the system, and then they will consider how in future they can fully implement it. Another project for indoor locations is under testing. We still not have results yet. We are trying to just linking the outdoor GPS to indoor. Okay, so if when you are using a cell phone and get into a indoor, then we will recalculate the indoor. This project is also we're working with our PolyU. But we don't. With the expectation we can have, if we can deliver around 2 to 5 meter accuracy. But maybe early next year we can have some more information and result for this test. Apart from RFID GPS, we also have projects working on video analytics. This is another project work for airport operations. Airport wants to know how many cars is still available for, say, in the evening when all the larger plane fly from United States, Canada, so almost 300 passengers will come out and pick up all this car. So the airport people need to maintain enough this trolley, enough when they exit. And we use a traditional CCTV to learn and to count how many trolleys in this area is. This project almost finished, and when it's implemented on early this year, first implemented, the machines tells around 40%. Okay, and last month, these systems, the accuracy can achieve around 85. So every day, besides of the calculations, we have a program, a machine algorithm, to learn that piece of a video. What exactly is it available trolley, or is being used by the travelers? And this is the phase 1 of the projects. And we have a phase 2 is besides of just counting the trolley, we also can use the same algorithm to counting people to queuing and calculate the queuing time so that the airline company can in real time opening enough airport counter, check-in counters to improve the airport service. Okay, now this is the round up some of the projects we've done with locations, and then we go on some of the sensing projects. We have lots of small warehouses in Hong Kong, and most of them are very crowded. So if we are talking about smart warehousing, besides of traditional pilot levels, if I need to transform this kind of a warehouse to store with sensors, this is a very tough job for these owners. So in this project, we use SIPIT and also design a PCB and also that can embed different kind of sensor. That means this time, this controller, I can just use the phone jack to measure humidity, temperature, and then I can switch to another 2 sensor. Next step, I can measure shocking sensor, UV, or light. This is a very cheap and easy to install system. And secondly, the router, okay, maybe next page, more easy to understand. We install this system to the Hong Kong Museum. This is the 3-story high museum. Each story contains around 20 meters. Okay, the whole infrastructure and also the exhibitor, they change all the layout every month. So they cannot put fixed sensor in here. And this full setup is we just use the power plug for the connector. And they can change all the sensor, and through wireless connections, they can get back to the controller. And this is our idea is if this can use, maybe the industry can support to produce this kind of electronic parts, so that they can just do it by themselves, and the commute users can very easily setting up all this kind of sensing network internally without any cabling. Okay. Also, this is another ongoing project, not finished yet, but we expect we have maybe coming 6 months. Maybe you all familiar with what's happening the day before yesterday. We have a black rainstorm, so many places in Hong Kong getting drowned, and people started to complain to the drainage service departments. And these projects, we are working with the drainage service department. In Hong Kong, we have, actually the drainage have 2 systems. One is the drainage, another is the sewage. I think most of the cities is doing the same thing. But in reality, you will find garbage waters in the drainage system and also stucking in the sewage system. So drainage is very interested to know actually the water level in real time, no matter it's in sunny day or in rainy days. As well as after the incident in Taiwan, they also want to measure any hazardous gas inside their drainage system. So we built a sensor device and also the communication, because the challenge is how you can emit signals underneath a manhole's well, because it's covered by such a 6-inch high metal plate. All of them it is. And we have done it and already implemented with trial. We have tried around 5 to 8 manhole in Kowloon East already installed. And ultimately, the whole project, we need to install around 100 to 300 sensors underneath all these manhole. This is okay. This is the dashboard view of the system we are delivered to the. So each manhole we will have the locations on the map, and sending up the real-time data back to the control office. And also you will see this is the real-time connect. Now is the this is the water level data. And the system is already keep running since from last month. And also we also build mobile apps for the workers or the staff working on the DSD departments, so that sometimes they will, if they can have because the mobile phones, they have cameras, so anything they can report and picking the pictures and send back to. Or sometimes they can see the pictures to make sure that they will not open the incorrect manholes cover. Okay. Now Amazon is left. Okay, we also done something similar. Okay. Because Kiva, they don't buy, they don't sell. Okay. And now maybe only 2 or 3 companies are doing this Kiva-like robots for warehousing. But the problem is we hardly find, if Hong Kong smart warehousing try to adopt this kind of AGV, it's hard to find a support locally. So our center tried to do something more close to the Hong Kong local usage. For example, Hong Kong, the land and space is so expensive. We cannot expect the Hong Kong warehousing people to build a huge warehouse like Amazon or Ma Yun. So most of them are sitting in multi-stories. And people and machines sometimes are working together. So we need to build something they can cross bugs. And also when people, they have sensors, when people are coming in, they will stop by themselves. And also more important is we also have tried to build a software and controlling system to control these AGVs, so that they can integrate to the user's current WMS system. And we are ongoing on this, trying the machines now. We have 3 types. One of AGVs under testing. One can move around 200 kilo, and another one is 450, and the most heavy duty one can up to 600 kilo. Okay, with the sensing and locations, then we come across big data. But this is another interesting piece of work we work with UST. What is these data are? We present this data to CRC, the Construction Council. Is in Hong Kong around 300,000 workers working on the construction industry. Okay, we input within this period every day. This data is working on which construction site. So just visualize that we can know which kind, how many workers in each construction site they're working in, and each construction site is contain what sort of type of work they are working on. And also doing some of our correlations. So we have using of course these tools to demonstrate this, and let the management people to use these data. But I'm not in this industry, so maybe after seeing that, I don't know how to what value can generate from this. Maybe I can know how many lunchbox I can sell next day, in which area it's better selling, or cold beer. But maybe if I got into combined with geographic any insight of the impact of the traffic nearby? Okay, so we can think about of this, but our center is really doing something can try to generate new data. Okay, so this is my presentation of this afternoon.